Okay, so this is going to be my review on the physics high-level paper that happened on the 19th of June. Again, as always, I sat these papers, so my opinion, I saw these first, and let's go. So, question one, we were expecting a F against A one for quite a while because that hasn't come up in quite a bit. We were either expecting this or a moments experiment. So both of them didn't come up for a while, so the F against A one was fine. A bit of a nice question, question six. Everything else should have been fairly standard material. So if you knew the diagram, you knew all of the errors related to it, then that should be okay. But part six was a very unique one. Part two was focal length of a converging lens. Again, one that hasn't come up in a while, and one that was expected to come up. It's one of the only light ones that hasn't come up in a while, so that was sort of expected. Again, some sound stuff here, but then it actually threw in focal length of a concave mirror into here somewhat, which again is I think is a first, but something that if you've done all the experiments, then you should know the main difference. Part three, latent heat of fusion of ice. Again, another experiment that we haven't seen in a while. So sort of following a trend here, where they aren't repeating experiments, say every 2 years or whatever. They are actually taking something they haven't included in a while. So that was actually a really nice experiment. A very nice question. Experimental question, anyway. I can't even speak. Uh, Question four was F against T. I have to correct the teacher from the academy that said F against L. The string length was constant, but it was F against T. So again, just a completely normal F against T fundamental frequency one. There were no real issues with this question at all. If you practice the experiments, you would have seen this question pretty much in other years. And then question five, which is one I don't think many people would have done. It's V against I for a copper wire and then some resistivity at the end. Um, People would definitely have had a lot of choice, especially between the first four. I don't think many people would have done question five. I could be wrong though. Now, question six. Oh, Jesus Christ! This question six was a bit of an oddball question. The first four were fine. I think these were all standard short questions. Describing an experiment. Um, Not really one I'd associate with question six, but whatever. A lot of the standard stuff. And then this question came up about how a lightning conductor works. I don't think it's in many textbooks. It's definitely in one that I use, Physics Plus, did talk about um, lightning in a sense and how lightning conductors are used, so that's fine. But it's not the same textbook everyone uses. So let me know if your textbook talked about lightning conductors. Um, but but apart from them, the rest of them were okay. But it sort of really restricted your choice. Um, if you want to sort of blitz through the paper, uh, very nice part L though. That was a great question. Question seven. Um, a lot of people are saying that this question you didn't necessarily have an advantage if you did applied maths. I guess if you worked a lot in circular motion, you could do quite a bit of it, especially the derivation. Um, but really, if you did do applied maths, then the projectiles one was actually fairly handy. Um, if you didn't do applied maths, it's still a handy enough question, but having done applied maths personally, it definitely helped to know the stuff about projectiles in it, which helps with this question. Overall, it was fine. Just a standard mechanics question. It wasn't too difficult. There wasn't any SHM in it, which was like, thank God. So that was a very manageable question. Question eight was a bit of a mixed bag, personally. Started off with magnetism, using F equals BIL and QVB in places. I don't think QVB was just BIL. Anyway, then it went on to sound. It actually had quite a bit on sound. This thing had 10 parts in it, which was quite a lot. Um, it started off fine. Like these two questions were an absolute gift. That they were very straightforward, and then just some theory stuff here, and then some sound intensity, which is a very popular question considering the algebra sometimes can get a bit finicky with r squareds and pi's being thrown around the place. um, as well as sound intensity doubled and 3 decibel stuff. So that was okay. Question nine, very standard. Started with semiconductors, Joule's law, and then some domestic electricity. So percentage efficiency hasn't come up in quite a while, which is an oddball one because a lot of people tend to confuse percentage efficiency a lot. Um, but it's a very mixed bag of questions. Electricity isn't my thing. It's not really my cup of tea, but I find it fairly alright. And then question 10 brought out some X-rays and gamma rays and some ionization, so a lot of modern physics here. And then some standard nuclear reactor stuff. So if you revise nuclear fusion or fission reactors, then this question should have been okay. Question 11, another electricity experiment, but I guess with the extra questions, they sort of double up on topics. I guess this year was electricity's time to shine. This was really focused on a capacitor, or on the capacitor. And one of these questions, I think, came from one, or was based on one in 2004. It was actually one of the earlier papers of the new syllabus that started in 2003. Um, introducing, well, not really introducing, but sort of using the Q over V and epsilon naught A over D ones in conjunction with the W equals 1/2 CV squared. But I think if students or if people really just focused a lot on, especially the circuitry theory end of things, then it would have been perfectly okay. A fairly standard classifier question. Now, question 12. This is probably one of the kindest particle physics questions I've ever seen. Like, complete theory for the first four about your fundamental forces, and then some more stuff about Wolfgang Pauli and basically his discovery of the neutrino and that stuff. And then some standard baryon lepton theory. Uh, this question, or the statement of this question might have confused some people because quark model isn't, it's not really something we come across. They mostly just talk about quark composition, but quark model is the same as a quark composition. So that was a fairly fine question. I'm not going to go into part B because I don't think many people did applied electricity. So I'm just going to skip that. Question 13, the comprehension. This time focus on light and the other source, John Tyndall. Um, yeah, again, a lot of stuff with light and colors. Now, I think a lot of people would have honestly skipped color theory because it's a bit of an oddball of a question. And it also introduced spectroscopy into here, as well as utilizing a formula I haven't actually seen in a while, which is E equals H times Ft minus F1 when talking about energy levels. So that was a first for me, at least. Doing all the exam papers all the way back to 2009, I think I did. I don't really remember seeing H Ft minus F1, so that's definitely a first that people had to be dynamic about. And then we get on to question 14, the two, you have to pick two out of these four. First one, some nice conservation of energy stuff. Um, it did lead you into using conservation of energy to this, but you could actually entirely use the Suvat equations for this and get the same answer. I actually did both methods, so conservation of energy and the Suvat, and it ended up working fine. I just prefer to use Suvat because I think it's just much better. Um, next was someone about half life and a radium even 224 to lead 208. This alpha beta particle combination stuff again very standard with a standard half life. Part C introduced actually the cathode ray tube, which means you have to talk about X-rays and the cathode ray tube if you chose them questions, which again is a first, and the spectrometer in question 13. But again, it's just some very standard CRT stuff, and then a nice diffraction one at the end. Yeah, again, there's the spectrometer again. Was it question 13 had the spectrometer in it? No, I had the spectrum. Oops, my apologies. Yeah, there's the spectrometer. So you could have avoided everything if you did A and B, but you're probably better off doing all four parts because of the amount of time that you have. But overall, it's a fairly solid paper, I have to admit. I definitely enjoyed this paper quite a bit, and by enjoyed, I mean I like the question variety in it, and sort of the questions that sort of separate the people trying to get H3s to those who want to get the top grades of H2 and H1. So definitely a very divisive paper, I've heard, but I found it fairly okay. It's a nice paper.